Hey, and welcome to Alchemist Camp, where we become better Elixir programmers by building things. And today we are going to play around with Elixir's binary processing capabilities and make some bitmap files. So just a quick refresher for anyone who needs it. I pulled up the file format summary for bitmaps. As you can see, they were made by Microsoft long ago, and the supporting applications are too numerous to list. In fact, I think it would be hard to find any modern computer that can't render them. Let's look at the file organization. So inside a bitmap file, there is a file header and bitmap data. And unless you're using a Windows 1X version of a bitmap file, you've also got a bitmap header and a color palette. So the bitmap header says some things about the kind of bitmap it is. Usually they're uncompressed, but sometimes they use run length encoding. And if you don't have 24 bits of data per pixel, you can pick a color palette. For example, you could just have a palette of 16 colors that are used within the image. And so you'd have to store those 16 color values, like the RGB values, inside the color palette, and then the bitmap data would only be using 16 colors or 4 bits per pixel instead of 24 bits per pixel. So we're going to use the Windows 2x, 3x, 4x form. We're actually going to do 2x because that's a fair bit simpler than 3x and 4x, and yet it's got most of the major features. So we can see there's a specific structure that was used to make the header. It's always going to be 12 bytes long. It's always going to be 14 bytes long. And then we're going to have this struct, which is going to be 12 bytes long. And if we're using 24-bit colors, we can skip the color palette because it's every single color is available. So we're just going to make a file header, bitmap data, then we're going to write that to a file, and that file will be readable by our operating system, by web browsers, by all kinds of stuff. Sound cool? I think so. Let's get to it. All right, we'll start by making a new file, and we'll call it bmp.ex. And this will be a module called capital BMP. And first thing we're going to do is we're just going to make a function to help us make that file header we can see over here. And I have bumped up the font size a bit. I've heard a few people are using smaller laptops and watching on YouTube at the same time as they've got a code editor on the same screen. So hopefully this is big enough. If it's still hard to see, just leave a message in the comments. File header. The file header is mostly stuff that we don't have to change at all. But there is one thing that we do want to keep track of, and that is the offset. The file header for version 2. This bitmap offset says when the image data starts. And this is going to change if we have a color palette. So we're just going to make the offset default to 26 bytes since the file header is 14 bytes and the Win2x bitmap header is 12 bytes. So we'll assume there's no color palette, and yet leave the ability for people to specify one if they want to. So the offset is 26 bytes by default. Then in this file header, we need the file type, which is always the string bm, the file size, which you don't have to specify. You can just set this file size to 0 if it's not compressed, and it'll be ignored. And then the next two blocks are always 0 for a written file. It's just used for old Windows applications that dealt with bitmaps in memory. And then the final thing to set is the offset, which we've got there. Word is, you may never have heard before, word is 2 bytes on these older systems, and in this file format it's 2 bytes, and dword is 4 bytes. We will start with file type, and file type is just the string BM. And remember, in Erlang or in Elixir, strings are binaries. So this is already binary. We don't have to do anything else to it. If we printed this out into a file and looked at the hexadecimal, it would be 4D2H. And then reserved, actually file size, file size is just going to be 0. And this has to take up 4 bytes. So I'll say size 32, because 4 bytes is 32 bits. So looking at this in IEX, you see 0, 0, 0, 0. That's because it's 4 bytes, and each of those bytes is 0. And if we were to say 1, size 32, then you can see a 1 at the end. Oh, actually, this is going to be a problem, because Windows uses, or I should say bitmap files are little endian, which means the 1 should be at the other side. So we have to say size with a little modifier. This just reverses the order of the bytes. Say the number 10 in binary. Actually, 10 is too small. Say we'll use 256. So that's going to be 0 in the least significant byte, and then 1 in the next one, because a byte only goes up to 255. It's there, but if we didn't have the little modifier, it would be on the other side. Anyway, we need the little modifier. Little dash size. Yeah, I almost never regret opening something up in IEX and messing around with it, because there's often something little and easily overlooked like that. Okay, 2 words that are set to 0. These are the reserved words, and I'm just going to handle both in one variable here. Reserved also equals 0, and I'll say little size just because everything in this file is going to be little size, and also 32 bits because we have 2 words, each of which is 2 bytes, so we want a total of 4 bytes. And finally, the bitmap offset, and that's by default 26. That's assuming no color palette. If there is a palette, we'll have to change that, but we're not going to worry about that for now. So bitmap offset equals whatever offset was passed in, little size, little endian of size 32. Okay, and we should be good. I'm just gonna comment on a couple of things here for clarity. So this file size is not actually 0, but it's 0 for uncompressed files, because then it's not needed. And reserved is always 0, just so that someone, such as the author, like us, can understand what's going on here later. Always 0. And number of bytes before image data. Okay, now we've got to output all of that, and It's just going to be a matter of putting it all together. So file type concatenated with file size concatenated with the reserved concatenated with the bitmap offset. All right, let's get rid of the white space and save that and load it up in the console. So compile bmp.ex unexpected token up. So it is bmp.file header. Does that look reasonable? 26, and let's see, it's the right number of bytes. Should be 14 bytes total. Remember, strings and binaries are essentially the same in Elixir, so we can use string.length. 14 bytes. Okay, on to the next part. After the file header, we need the win2x bitmap header. Okay, and this has two useless fields. It's got a size saying its own size, which is always going to be 12 bytes. I shouldn't say useless, since there are other types of bitmap formats, like it could be a 3x or a 4x format. This size does at least let the consuming program know that it is of this version. Number of color planes is always going to be 1. So this is going to be 12, this is going to be 1. Width and height are going to vary, and bits per pixel can also vary. According to the API, bits per pixel can be 1, so that would be like monochrome, each pixel is just on or off. 4, which would be 16 colors. 8 bits, which would be 256 colors, or 24 bits, which is where each color has a value going from 0 to 255, just like they would on a web page. If you use 24-bit data, there's no color palette. So that's what we're going to assume as default, just because it'll make things a bit easier. Call this win2x header. Take in a width and a height and bits per pixel, which will default to 24. So we'll start with size. And according to the spec, it's a D word, double word, so that's going to be 4 bytes or 32 bits. And it's still going to be little endian. Next is the width and then the height, each of which are shorts, which are 2 bytes or 16 bits. We're going to use the width and height passed in the parameters. So the width passed in, and then little endian 16. Then height is almost the same thing. Okay, then planes is always going to be 1. I'll just copy this one down. All right, then finally is bits per pixel, which was passed in. This is also a word, so that's 16 bits. And actually planes is also 16 bits. Bits per pixel is passed in. And we'll just call this variable BPP. Then to return the whole header, we'll just concatenate it like we did before. So it's going to be size plus width, then the height, and then the number of planes, and then the bits per pixel. Save that and check it out in IEX. Undefined function bitmap offset. Ah, looks like the autocomplete led me wrong. bits per, there we go. Okay, the file header we've already seen. Let's check out the win2x header. Yes. Say it's a width of 5 and a height of 5. 5, 5. Okay, and 24. Good. Okay, that looks like that will work. Now we need some example data. So we've looking back at what has to be in the file. We have the header, we have the bitmap header. We're not going to have a color palette because we've got 24 bits per pixel. So next we need bitmap data. So the image data section is a little bit more complicated. We're not using any kind of compression, so that will simplify it a bit. Uncompressed data is a series of values representing either color palette indices or actual RGB color values. We'll have RGB color values since we're doing 24-bit colors. Pixels are packed into bytes and arranged as scan lines. Each scan line must end on a 4-byte boundary. So 1, 2, or 3 bytes of padding, they follow each scan line. We'll start off just using width and height divisible by 4 so that we know we'll end on a 4-byte boundary, and then deal with the padding after we've got that working. So let's make a function called example data. And this will just generate the image data part of the file. And it's going to take in a width and a height. All right, so we'll have lots of scan lines, and each of those lines will have a bunch of pixels in them. So the easiest way to do this is with comprehensions. So we'll have rows, and then inside the rows we'll have items. For row number 1 up to the height, because whatever the height is, that's how many rows there are. We'll be putting all this into a binary, so use into. Do, then inside of the 4, we're going to have the items, so we'll have another 4. So for item, numbering 1 up to the width, and it's still going to be into a binary. This one is not correct. There we go. Do. The order is kind of backwards from normal. Instead of red, green, blue, it's blue specified first, then green, then red. Let's start with kind of a big number for blue, so big-ish. So they're all from 0 to 255. We'll start with blue at 100, and then it'll go up by 5. Actually, it'll go up by 5 every item. So 5 times item number, and this is all a little endian byte. So byte is size 8, comma, and this is going to get long, so I'm just going to go 1 per line. Then let's see what we do for green. Green will have go up by the rows. So 2 times row. We'll make more rows than columns. We'll make it a tall, thin bitmap. 2 times row, and this is also little endian size 8. And then finally we'll make red go up both by the columns and the rows. So we'll say 5 times the column plus 1 times the row. 5 times item plus the row. Little endian size 8. And we're just going to pretend that padding is not a problem. And we're just going to use width and a height that are both divisible by 4, and then everything should be good. Recompile. And that seems to have worked. Let's do example data for width 32, height 100. This is blue, green, red, blue, green, red. That's kind of hard to process. It looks like it's right, but let's actually just print it out into a file. That's probably the easiest way. So we'll make a save file function. Save, and what do we need? And we need a header to be passed into it. We need not the file header because that's always the same, but we'll need the win2x header, and we'll need the image data. I'll call that pixels. File.write. I'm not going to worry about errors and edge cases. File name, then the file header function to just get that same header. We'll append that to the win2x header. It's passed in, and then we'll append that to the data that's passed in. Okay, that should save a file. And now let's make an example file. And the example file will be generated with a width and a height we pass in. And we'll save, oh, we need a name too, I guess. Name, we'll default that to hello.bmp. And we'll save name win2x header, passing it the width and the height we got in. And then example data using the width and the height. Okay, so if this works, what we expect is we expect a file of a width. You know what, let's just give it a width. We'll give it 32 as a default. And we'll give a default height of 100. So what we expect, if this works, is running example file will create a bitmap of the name hello.bmp. Let's full screen this. Hello.bmp, and get a file header from up here, which is always the same. Create a win2x header using the width and height we give it, like say 32 and 100. And there'll be no color palette because we're doing 24-bit pixels. It will create that example header, and then it'll create example data using the same width and height as the header so that it should all match up. And this data is just going to be that number of rows and that number of columns inside the rows, and it's going to become bluer as we go from left to right, greener through the rows, and then redder moving diagonally along the rows and the items. Let's see if this actually works. This is always a bit dicey when you're constructing a file. Undefined function data. Oh, that's just pixels. Okay, and I'll import BMP so I don't have to keep on typing it. Example file. We'll just default everything. Width 32, height 100, name hello BMP. Okay. Is it okay? Did we get one? Hello BMP. And that is getting greener as it goes up, redder as it goes to the right, and it's getting bluer going to the upper right, but it's basically just white once we get to that point. Looks good. All right, let's see what happens if we have a different size though. Say we had an example file with a width of 31 instead of 32, yeah, then everything is broken. That's because of the padding. So let's fix the padding. Get out of full screen just so we can see this again. Each scan line must end on a 4-byte boundary. So 1, 2, or 3 bytes of padding follow each scan line. Okay. So what I'm imagining is we have some line of items. So we used to have 32, and for each of those 32, there would be a blue, a green, and a red byte. So that was 32 times 3 bytes. That's divisible by 4 because 32 is divisible by 4. So we'd be looking at something like 32 times 3, 96. The remainder of 96 divided by 4 is 0, of course. But when we had 31, 31 times 3 is 93. The boundary that was closest to 93 is 92, because 92 is divisible by 4. We're 1 over it, so the remainder of 93 divided by 4 is 1. And we need 3 bytes of padding to get up to 96, which is the next 4-byte boundary. So in each case, if there's a remainder that's greater than 0, we want 4 minus whatever that remainder is in padding times 8, because it's bytes instead of bits. So it's a little bit messy, but not terribly bad. We'll just add a padding calculation in here. So bytes past boundary, we'll just call it bytes past, is going to be the remainder of 3, because 3 is how many colors there are, 1 byte per color. So 1 for red, 1 for green, 1 for blue. 3 times the width, because that's the number of items in a row. The remainder of 3 times the width and 4. Then the padding is going to be 0 if the remainder is 0. And then if the remainder is not 0, it's going to be 4 minus the bytes passed times 8. Padding equals if bytes passed is greater than 0. You can't just do an if bytes passed, because in Elixir 0 evaluates to true, unlike C or a lot of other languages. So if bytes passed is greater than 0, then we'll do 4 minus bytes passed times 8, since it's going to be specified in bits, but we're counting the number of bytes to add. And if it's not, then our padding is 0. So the value of the padding is going to be 0, and the size is the size that we calculated above. Doesn't matter if it's little endian or big endian, because the value is 0. We'll make another file, and this one is going to be 31 pixels again. And that is not what we want. Shoot. Okay, let's make a smaller one. This one will be, let's make this one 7 pixels by 10 pixels. And that still, I still see a crease down it, which suggests that it's not what we want. Let's make it 7 by 100. Yeah, that's definitely not what we want. Okay, so fortunately, Visual Studio Code has a hex dump. We can look at the hex. So that's BM. We can see that over here. Okay, so the header is 26 bytes. Then after that, we should be in the file data, and we should see some padding. 7 times 3 is 21, so there should be 3 bytes of padding. We should see 0, 0, 0, 0, E, 0, C, 0. Nope. Okay, so let's go back to the bitmap, and we will temporarily change these 3 lines and just make it super simple. We're just going to make the pixels plain red. So it's going to be blue is first, so it's going to be 0, size 8, comma 0, size 8, comma 255, little endian, size 8. So blue, green, red should be totally red, and then have the appropriate padding. that is not right. We do see some red, but there are holes in it. So 0, 0F, so that's red, blank space, red, blank space, red. That's because we're adding the padding to every single item instead of to every single row. So this should not be here. Instead, that should be on the rows after all the items. Should be good. Compile, import, and make our tiny example file. And it's solid red. Excellent. Red pixel, red pixel, red pixel. There's our padding. Red pixel, red pixel. Okay, good, good, good. So now we should be able to go to our original pattern. And make sure we got all the commas we need. Save that. Recompile, reimport. We'll do an example file size 31. Where's our bitmap? There we go. And that is beautiful. That is pretty much what I expected. Now let's try it with a different size. Say we just go 14, which is not divisible by 4. Nice. 29 by 5. Keep on hitting backspace instead of space on this keyboard. Okay, so that is a win. We have mastered the bitmap, sort of. We can make simple bitmaps. We're making bitmaps with 24-bit colors, but this is the basic idea. And your challenge, should you choose to accept it, is to make a bitmap that includes a palette. So the first task is make a palette that just monochrome, just 2 colors. You're going to have to define a palette, and this offset is going to change in the file header because you've got to account for the space used up by the palette. In the palette, you'll specify what your colors are. You just pick 2 colors, and you'll change the bits per pixel down to just 1 and make a picture. Then after you've done that, try making a 4-bit palette. And at that point, you should be pretty comfortable making whatever uncompressed bitmap that you want. In a lot of programming languages, we would need to use libraries to make all this, but with Elixir, dealing with binaries is not so difficult. And it's pretty fun. I will add a link to the reference we were looking at throughout the video. You can see the address up here though, in case I forget. File format.info/format/bmp/egff.htm. If you enjoyed this lesson, then definitely subscribe. Definitely tell your friends about it. Go to alchemist.camp. Keep track of the progress, the new features being added by the week, and do the challenge. I really think that just watching videos, especially watching videos passively, but even coding along with them, it's not enough to really make the concepts sink in. You kind of have to go out and build something yourself off the rails without anyone helping you through it, and run into some things that you may have misunderstood, or the pain of some sort of bug cropping up, because that pain is really what makes a lot of this stuff memorable, and it's what forces you to update your mental model about how a program works, or how a system works, or even how a file format works. So hope you do the challenge, and until next time, code on.